This video will show you how to use the calculator to solve a system of equations with three variables. Specifically, you will solve the system of equations using the matrix equation A times x equals b, and solve for the variable matrix x. Solving for the variable matrix x gives you the matrix equation x is equal to A inverse times b. Note that matrix A must be a square matrix, that is, the number of rows must equal to the number of columns. Therefore, the dimension of matrix A is n by n. Also, the inverse of matrix A must exist. If the inverse of matrix A does not exist, then it is best to use reduced echelon or row reduced echelon form to determine if the system of equations has no solution or infinitely many solutions. Refer to the videos matrix reduced echelon form or matrix row reduced echelon form. For example 1, we would like to use a matrix equation to solve the following system of equations. X plus 3y plus 2z equal negative 1, negative 3x minus 11y minus 8z equals 3, 2x plus 5y plus 2z equals negative 3. So let's go ahead and input this into the matrix. So let's go second function and matrix. And our first matrix, matrix A, says it's a 3 by 3. So we don't need to edit the dimensions, but we do need to edit the cell values, since this is a matrix that was existing from another example. So let's select enter here. Now the dimension's okay, 3 rows by 3 columns, because what we're going to do is we're going to enter the coefficients of the variable terms here. So what we're going to have is we're going to input 1, and that's fine, and then we move over to the right and then enter 3. 2, enter, negative 3, enter, negative 11, enter, negative 8, enter, 2, enter, 5, enter, and then 2, enter. Okay, so here's our 3 by 3 matrix. Now let's go back to matrix, and now we're going to enter the values on the right side of the system of equations, the constant values. So let's go down to matrix B. Now matrix B will be 3 rows and 1 column. So the dimensions here are fine. So we will move over to edit, matrix B, and we want to enter the constant values. So let's move down. So we have negative 1, 3, and negative 3. Let's quit out of this. So what we're going to do now is we're going to use the matrix equation A times x is equal to b. We're going to solve for x, which says that x is equal to A inverse b. So once we solve for the variable matrix x, we will be able to find our solutions to the system of equations. So let's go ahead and take A inverse. So we go second function, matrix. We want matrix A, select enter. You want the inverse of that. Now we will multiply that by matrix B. So second function, matrix, and then matrix B is number 2, and we select enter. So this gives you the x value, the y value, and the z value. So x is equal to 0, y is equal to negative 1, and z is equal to 1. So let's clear the screen. For example number 2, we would like to use a matrix equation to solve the following system of equations. P subtract 3q subtract 2r equals 2, q minus 3r equals 2, 3p minus 11q equals 5. So once again, let's go ahead and input this information into our matrices. So let's go second function in matrix. So once again, matrix A is a 3 by 3, so let's move over to edit, select enter. Let's move down to edit our cell values. Okay, so we have 1 for our first entry, then -3, so let's move over, -3, then -2, and then we have 0p, so select enter, and we have 1q, then -3r, and we have 3, and then -11, and we don't have any r value, so 0. Okay, so here's our 3 by 3 matrix. Now let's put in our matrix B, which is the right-hand side of these equations. So let's go to second function in matrix, and we will select edit. We want to edit matrix B, and matrix B is 3 by 1, 3 rows by 1 column, so that's fine. So select number 2, and our constant values here are 2, 2, and 5. So let's go ahead and quit out of this. Now remember, we're going to use matrix A times the variable matrix X is equal to matrix B. And then once again, when we solve for the variable matrix X, we get X is equal to A inverse times B. So let's go ahead and do that. We want to take A inverse, so second function matrix. We want matrix A, select enter. We want the inverse of that. So there's the key, and that's multiplied by matrix B. Now you don't have to put the multiplication symbol in. We can just simply go second function and then matrix, and then select number 2. So A inverse B. That's the same as A inverse times B. Okay? Now we select enter. And here it gives us an error. It tells us that there's a singular matrix. What this means is that A inverse does not exist because matrix A is singular. So for this example, it is unclear whether the system of equations has no solution or infinitely many solutions. Therefore, it is best to use reduced echelon form or row reduced echelon form. Refer to the videos that illustrate how to use either form. For this example, row reduced echelon form was used, and the resulting matrix is shown on the screen to the right. Now if you notice, the third row has 0p plus 0q plus 0r, and that's equal to 1. So what that means is the left-hand side of the equation is equal to 0, and the right-hand side of the equation is equal to 1. Well, since 0 equals 1 is not true, there is no solution for this system of equations. This is inconsistent, so therefore there is no solution. Okay, let's clear the screen, and we'll clear again. Now we will go to example number 3, which says, use a matrix equation to solve the following system of equations. X minus y minus 4z equals 4, minus 2x plus y plus 6z equals -7, and 2x minus 5y minus 14z is equal to 11. Now we will input the values into the matrices. So second function matrix, we will edit matrix A, select enter. Let's input these cell values. So we have 1, that's fine, move over. Then we have -1, enter. Then we have -4, and then enter. -2, 1, 6, 2, -5, and -14. Okay, so that's matrix A. We will now go back into matrix and let's edit matrix B. So we need to move over to edit and then number 2, and let's move down, and our right hand side of the system of equations says 4, -7, and 11. Select enter. Okay, so let's quit out of this. Second function quit. And now we will once again use the matrix equation AX is equal to B, solve for the variable matrix X, and we get X equals A inverse B. So let's go ahead and do this. So second function matrix, we want matrix A, and we take the inverse of matrix A, so use this key, and multiply that by matrix B, so second function matrix, and then matrix B, number 2. Remember, we don't need to put a multiplication sign in between these two, so it saves you a keystroke. So now select enter, and once again here it gives us an error. It says singular matrix. So what this means is that A inverse does not exist because matrix A is singular. So for this example, it is unclear whether the system of equations has no solution or infinitely many solutions. Therefore, it is best to use reduced echelon form or row reduced echelon form. Refer to the videos that illustrate how to use either form. For this example, row reduced echelon form was used, and the resulting matrix is shown on the screen to the right. So as you can see, the third row says 0x plus 0y plus 0z is equal to 0, which says that 0 is equal to 0, which is a true statement. This tells you that there are infinitely many solutions. So recall what we need to do is we need to set up a parameter. And usually we take the third variable, which is z, and we set that value of z equal to the parameter t. So we're going to let z equals t. Then we use back substitution to solve for y and then x. What we end up with is x is equal to 3 plus 2t, y equals -1 minus 2t, and z is equal to t. This is called our general solution. Now if we choose values of t, and since t can vary, we will have infinitely many solutions. So we can pick any value of t that we want and get many different solutions. So we will use 2 different values of t and get 2 different solutions. So if t is equal to 0, then x equals 3, y equals -1, and z equals 0. If t is equal to 3, then x equals 9, y equals -7, and z equals 3. Now, let me emphasize here that using the matrix equation AX equal B and then solving for the variable matrix X equals A inverse B is perfectly fine to find the solutions for a system of equations. However, if you do get an error that's telling you that A is a singular matrix, then it is best to use row-reduced echelon form so you can tell whether there is no solution or infinitely many solutions. This concludes the video on using the matrix equation for finding a solution to a system of equations.